Is Moore's Law dead? What are the implications for artificial intelligence? How about algorithms? Are they able to pick up the slack? Spoiler alert, algorithm efficiency gains are even more powerful than Moore's Law advancements in compute. And I've got a secret sleeper factor to show you at the end that's even crazier than these two. Data aggregation, advancements in algorithms and compute all contribute to AI's growth. We know that data continues to be produced, stored, and utilized at exponential rates, and some say that compute growth is slowing. What about that third area? Algorithmic progress. Is that helping or hindering AI's growth? We've struggled to fully understand the growth of algorithms, but the easiest way to express growth is to compare it to something in the past, correct? Look at this simple graph. Over the past 2 decades, algorithms have grown 500,000 times better at solving mixed integer problems. Over that same time frame, Moore's Law was only responsible for about efficiency gains of 1,500 times. Recently, OpenAI compared the amount of floating point operations, FLOPs, needed to train image classifiers to the 2012 standard of AlexNet, and they observed a factor of 44 difference than today's from 2012. Basically, it's 44 times easier or cheaper to train an algorithm to recognize images. So, although Moore's Law may be continuing to slow, in mixed integer problem and ImageNet examples, algorithms are growing faster and gaining efficiency at breakneck speeds, doubling every 13 to 16 months. Here's the algorithm growth over that 7 years. Over time, exponentially less compute is needed to train EfficientNet to the same level as AlexNet. Now, let's switch the chart and look at the efficiency gains another way. These algorithms are not just growing, they're absolutely exploding. The training efficiency factor has shot up almost parabolic. The beauty of exponential growth is that your gains are compounded over time. These algorithms are showing a factor of 44 gain in efficiency. What would Moore's Law predict based on hardware and compute advancements? Only an 11-fold gain. Training AI now requires fewer iterations of learning, aka epochs, and also fewer floating point operations, or flops, aka just calculation, per training iteration. This is great. This means that future applications of artificial intelligence will continue to be easier and cheaper and faster, potentially springboarding novel advancements and developments in artificial intelligence. The same way that we saw Moore's Law affect computers from large warehouses to the super powerful smartphones in your pocket and their immense problem-solving ability. This is promising. The future is bright. These results observed by OpenAI are not just applicable to image recognition. We've observed even more significant doubling times in things like DeepMind's AlphaGo, where they defeated Lee Sedol, and OpenAI 5, defeating the world champions at Dota 2. Check out my video up above on OpenAI 5 and what they were able to do. It showed some really awesome ability to excel over long time horizons and messy and uncertain environments. The future is indeed bright. We're seeing a confluence of reinforcing advancements here. The increase in data, compute, and algorithms is producing exponential growth on top of exponential growth. Now, because companies and organizations are recognizing the massive potential in AI, they're throwing liquid oxygen on this fire. Increasing spending from AI research and development and experimentation to application is likely dwarfing both Moore's Law and these algorithm gains that we're talking about. Of course, all these growth factors are hard to attribute, but it's easy to understand that these trends help propel each other and the exponential growth of AI. Buckle up. Next stop, more great, awesome breakthroughs. This is Jerry. See ya.